Okay, class, picking up where we left off at, we're on compound interest, continuous compounding. Some banks use continuous compounding where the compounding periods increase infinitely, meaning the compounding of interest every trillionth of a second, every quadrillionth of a second, etc. Continuous compounding sounds fabulous, however, it yields only a fraction of a percent more interest over a year than daily compounding. Most credit card companies use continuous compounding on their interest rates. Although it only amounts to a fraction of a percent, it adds up very quickly in interest charge to customers. The formula to compute the amount if interest is compounded continuously is A is equal to P times e to the RT. Now, E is considered to be a number, where E is approximately 2.71828, and you should be able to find E on your calculator. If not, you can come to class and I will show you where it is on your calculator. Now, E is an irrational number like pi. A more thorough definition of the number E is developed in calculus. You can compute E to a power using the E to the X button on the calculator. Use the key to enter E to the first and verify that E is approximately equal to 2.71828. The formula for compound interest. After T years, the balance A in the account with principal P and annual interest R in decimal form is given by the following formulas. For N, compounding periods per year, A is equal to P times 1 plus R over N to the NT, which we basically did in the previous problems on the previous video. Now we have for continuous compounding, A equals P times e to the RT. Now example, you decide to invest $8,000 for 6 years and you have a choice between two accounts. The first pays 7% per year compounded monthly. The second pays 6.85% per year compounded continuously. Which is the better investment? So what we need to do is do both of these and then do a comparison. Okay, so now we would do the compounded monthly. That's A is equal to P times 1 plus R over N to the NT power. Then we're going to compare it to A is equal to P times e to the RT. So now we will go through and substitute. We have P, which is 8,000, and 1 plus, we have our rate, which is 7%, which is 0.07. All over, it says it's compounded monthly, so N is 12. And then we will have 12 times 6, because T is 6. So now, we will have A is equal to 8,000 times. Now, if we put this 0.07 over 12 in the calculator, it's going to give us a repeating decimal. So we're just going to leave it as this for now. And 12 times 6 is 72. Now, we could put all of this in our calculator, and that will give us $12,160.84. That's how much will be earned on that account. Now we go to this next account. We substitute. We will add 8,000 for P, E, R is 0.07, and T is, 6 years. Actually, made a little error here with R. There's a different R for this compounded continuously. It's 6.85, so it's 0.0685 times T, which is still 6 years. So now we will have A is equal to 8,000 E, and then we would take that to the power. Actually, it'd be easier if we just went on and put this in a calculator and solve. Put 8,000 times e to the 0.0685 times 6. Now remember, you have to multiply this first, and that will become your exponent. So I'll just go on and write that out. That'll be A is equal to 8,000 e to the 0.411 power. Okay, so now we will have A is equal to, after we put this in our calculator, this will give us 12,860 $76.98. So the best value would be to compound it continuously. So it'd be compounded continuously is the best. Okay, so now we go to our next example. If you invest $1,000 at 4% for 7 years, how much would you have if A, the interest is compounded continuously? So we will have A is equal to P times e to the RT. So we have A is equal to P is 1,000 times E. Our rate is 0.04 and our time is 7. Okay, so now we will have A is equal to 1,000 e to the 0.28 power. So now we will have 1,000 times e to the 0.28 power, which will give us our final answer of $1,323.13. And that will be our final answer for compounding continuously. Now we want the interest is compounded quarterly. So we will have A is equal to P times 1 plus R over N to the NT. So we will have A is equal to P is 1,000. 1 plus the rate is 0.04. N is said compounded quarterly, so that would be 4. And then we will have N times T, which would be 4 times 7. So this will lead us to A is equal to 1,000 times. Now if we add everything inside of this parenthesis, it will give us 1.01. And 4 times 7 is 28. So our A is equal to $1,321.29. Now we come here to C. The interest is compounded monthly. So we will have A is equal to, we will use the same formula. So we will have 1,000 and we will have 1 plus 0.04 all over 12 because it's compounded monthly, and our N is 12 and our T is 7. So we have A is equal to 1,000 times. Now we could leave this 0.04 over 12, so it'd be 1 plus 0.04 over 12, all taken to 12 times 7 is the 84th power. So we need to add this and then take that answer to the 84th power and multiply by 1,000. And that would give us $1,322.51. So you need to put this in your calculator. Now we go here to D. The interest is compounded daily. Now typically with banks, they consider daily to be 360 days. So we will use the same formula, but this time we will use days. So it'll be 1,000 times 1 plus 0.04 over 360. And then our N is 360 and our T is 7. So we have A is equal to 1,000 times. Now we will have 1 plus 0.04 over 360. And 360 times 7 is 2,520. Now if we put this in our calculator and multiply, this will give us $1,323.11. And that will be the final answer here. Now we come to the next example. It says, if you invest $500 at 4% for 100 years, how much would you have if the interest is compounded continuously? And we have a few more examples here. But let's go here with continuously. A is equal to P times e to the RT. So A is equal to, our present value is 500. We have our E, Our rate is 0.04, and our time is 100 years. Is 100. So this will end up being A is equal to 500 e to the fourth power. So our final answer would be A is equal to $27,299.08. And that would be our final answer. Now we come here, the interest is compounded quarterly. We basically use the same formula as we used up and actually here, which is B, C, and D. We use this same formula. Now for every problem, I'm not going to write out the formula. So I'm just going, some problems I'm just going to jump right to it. So A is equal to, now we know P is 500 times, it'll be 1 plus, now we know it's R over N. Our R is 0.04, and our N, since it's quarterly, is 4. And then we would do N times T, it'll be 4 times T is 100. So now we will have A is equal to 500 times. Now this will end up giving us 1 plus 0.04 over 4 will give us 1.01. Okay, correct that. 1.01, and 4 times 100 is 400. That will be our exponent. Now we will have A is equal to, that will give us $26,762.06. Now, we want to do it when the interest is compounded monthly. So we have A is equal to, it'll be 500 for P. 1 plus our R is 0.04. It says compounded monthly, so it's 12. And our exponent will be N times T, which is 12 times 100. Now, this will give us A is equal to 500. We would just leave this as 1 plus 0.04 over 12, and that's taking the 1200. So we will have to the 1200 power. So this will give us A is equal to $27,118.09. And that will be the final answer here. Now we go here to D. It says compounded daily. Same formula, but remember our daily would be 360 days. The rate is 0.04. Daily is 360. So we would take N 360 times T, which is 100. So we will have A is equal to 500 times 0.04 over 360 to the power of 36,000. And this will give us the final answer of $27,293.01. And that is our final answer. Now we come to our next example. It says if you invest $500 at 4% compounded quarterly for 100 years, how much would you have? So we will use this compounded formula. So it'd be A is equal to 500, which is our principal, 1 plus our rate is 0.04, and the amount of times the interest is done is 4 times a year. Then we will have how many times the interest is collected times the time, 4 times 100. So we have A is equal to 500 times, this will give us 1.01, and then to the 400th power. So our final answer would be A is equal to $26,762.06. Okay, now we move on. Our next problem, we would do the same thing, but our interest rate has changed. So it's the same exact process, but instead of 0.04, we have 0.05 divided by 4. So it'd be 4 times 100. So we have A is equal to 500, and in parentheses we have 1.0 125